We'll get started. So my name's Pat Altimore. Thanks for everybody for coming at this last session. I'm a consultant. I work actually in services, but I work a lot with the Windows product group, working with top-tier partners on not only application compatibility, getting their applications on the next OS, but also for development. So I work with ISVs working on development technologies, and one of my specialties is multi-touch. So I'd like to find out from everybody kind of what development platform they're familiar with. How many people are native code developers, C++ developers? Okay, we've got a few. How about WPF? Okay. How about Silverlight? Okay, good. I thought this guy here, he was going to raise his hand for all of them. How about web technologies? Anybody do HTML? HTML5? Okay, good. All right, so we're going to talk about all those questions that I asked. We're going to talk about all of those and which is the right platform for, or how you decide to pick the right platform. Is it going to be based on your skill set? Is it based on your requirements? Is it based on something else? Maybe platform functionality. And that's what this talk's about. We're gonna look at code. We're gonna look at the pros and cons of each development environment, and we're gonna look at some shipping apps that actually use touch on Windows 7. So since Windows 7's shipped, they actually built APIs into the operating system. And there's a lot of hardware that actually supports the touch interface today. And there's a lot of kind of buzz around slates and tablets because kind of the phone pushed that interface. So we have multi-touch gestures on the phone. And now it's moving to tablet. Microsoft's calling theirs Slate. Their Slate PCs is very similar to what we did with tablet. So we've got those devices coming out today, or you'll start seeing them. I've got one right here. Laptops. So generally on the laptops, you see them support the traditional tablet pen stylus, as well as using the digitizer to do touch with your finger. There's also some other classes out there, all-in-ones. You'll see these, they're designed for kind of like a kitchen environment. So you put it in your kitchen and it supports two touch. It's an optical based. It generally is for big screens because they can, actually the way the optics work, they can keep the cost low on a large screen. And then also there's some displays that you can add to just a traditional desktop PC and plug it in USB and you get multi-touch. So the display actually has the technology, and then through USB and a driver you can leverage the Windows 7 multi-touch. So you've got all this. So the point of this slide is really to show that it's not just about tablets. It's about a lot of different PCs. And again, it runs on 7. So if you design your application to not only work with touch, but also with the mouse and keyboard, you can target these special class devices as well as all the other PCs out there. So I wanted to talk a little bit about the Slate PCs. I've got one of them here. I'm going to gently lift it up. I've got it all wired up here for the demo. But this is the Asus. It looks a lot like an iPad. It doesn't have a keyboard. That's an important point that we'll talk about. It has the specs here that you can look at. It's 2-finger touch. And it's a pretty a well-equipped machine. So a traditional laptop class PC So it's actually really nice. It runs Windows really well, and the touch experience is pretty good on it. And then as we move to the right on the slide, we've got the XOPC, very similar as well. It's a little lower class processor. And then finally the Dell Duo, which I have here. I've got one of those. And this does an interesting, you've got the traditional clamshell here. And then if you flip this, then it goes into tablet mode. This is a lower cost machine, but the performance is around like a netbook performance. Okay, so we've got a big range here that can play a factor in how you develop your application as well. You've got to think about all the different devices that are out there and the different levels of hardware as well. So let's talk a little bit about when you design your application, what are some of the fundamentals in designing your application. The first thing you want to do is have a nice clean layout, because generally you want to have your controls placed in a way that's nice and clean, nice and friendly, kind of inviting the person to touch it, getting a way to understand what the buttons actually do. We can see these buttons here. The first one looks like a play button, the second one's a home button, and the third one's a print button. So you want to have a nice layout. That's the first thing you want to do. Next, what I want to talk about is just the size of your finger. If you think about the size of your finger, it's much bigger than a mouse pointer, right? So you need to think about that when you design. You want to have nice big buttons. You want to, even if you can't have a big button because of your UI, you want to have the touch area at least be big. So the button might be small, but you want to correct for the size of the finger. So if you have an existing application and you're enhancing it for touch, you might not have a lot of real estate, but think about how you want to handle the touch of the finger, because the finger's actually big. You want to be consistent. And what this means is there's a lot of touch devices out there, especially the phones, that kind of already set the stage for what people expect for a touch experience. What I mean is, when you do a pinch, that's a zoom in, right? Or zoom out. Zoom out. And then when you expand, it's the opposite, zoom. So you don't want to create gestures that don't make sense, that confuse the person to say, oh yeah, to do this special functionality, I need to use 3 fingers, or I need to click and rotate, or something like that. So you want to be consistent, kind of look what's out there. There's already an expectation on how touch works. And performance, and this is really critical, especially we talked about the different class devices here. So you've got all the way to a low-end netbook class, all the way up to something that's a kind of a beefy laptop class. So performance is kind of critical. If people see lag, or they're not getting the feedback from the touch, they'll have a poor experience. So that plays a role in what development environment you choose, what your requirements are. All that stuff plays a part. So when you build your application or create your application, you want to think about performance from the beginning all the way to the end. Because if you don't think about it early on, you could potentially have a poor user experience. So now I'm going to walk through the different levels of touch. One nice thing about Windows is, so like this device here, this is a Windows 7 device. It's running Windows 7. I can run existing applications. I can run, Microsoft Word. All those applications, existing legacy applications, aren't designed for touch. However, I can still use them on this device because under the covers, what Windows does is if you don't handle the touch APIs, it converts them to mouse messages. So even if you don't use the APIs or some of the enhancements in the development platforms, you can actually take a standard app, do some tweaking, and make it touch-friendly. So the first thing we want to talk about is touch-friendly. So what you want to do is have a decent-sized control targets. So something that a finger can click. So you don't want to have a lot of buttons scrunched together, a lot of links scrunched together. You want to have enough space that when somebody clicks, they get what they expect. Gestures supported through mouse and keyboard. There's a set of mouse moves. Well, actually, there's a set of gestures that get converted to mouse moves just by default. So, for example, if I touch and click, that's a mouse button down, right? And then when I release, it's a mouse button up. If I do a pinch, that's a control mouse wheel. And so if your application supports those gestures, you can actually have a touch experience even without using the APIs. So I worked with some ISVs that their application didn't really support touch at all. But we tested it, and because they followed those guidelines of what to use with the mouse, their application actually performed really well. Like they supported the pinch zoom, so they supported control mouse wheel and to do the zoom, so that naturally worked. They had nice big targets. It actually worked well. The example here that I have on the screenshot, this is actually Wild Tangent's game interface. So if you download Wild Tangent, usually ships on PCs, or you can download this app. This is actually, they did not design this for touch, but it does actually provide a good experience. They just had to do a little bit of tweaking to actually provide a pretty good touch experience. So that's the first step, is think about touch-friendly. The next level is touch-enabled. So now you're starting to think about, what's the frequent use case? I want to bring those to the attention that they support touch. When somebody clicks with their finger or touches with their finger, you want the feedback, meaning if it's zooming or you're panning, whatever that gesture is, flicking, it happens at the point of contact. That I'm not doing a pinch gesture down in the corner and then this text up in the right-hand corner is zooming. You want to have it happen at the point of contact. And then have really good feedback. So you want it to behave very naturally. So you want to, when you do a pan, it acts like you're pushing a piece of paper around, right? So that's touch-enabled. Touch Optimize is the best you can do. This is usually you're starting to actually implement the APIs, and you have frequent tasks right on the UI. It's designed for touch. You generally have some kind of physical feedback mechanism, meaning that if I do a pan and I let go with a rapid rate, inertia takes over and I get a slow deceleration. And then think about things like what happens if I'm dragging or I'm clicking and there's some inaccuracy, to be kind of resilient to that so that the user doesn't get frustrated with the touch. So that's touch optimized. Tomorrow there's a session I'm co-delivering with a partner that actually worked on this application right here. This is, I'll show it in one of the demos. He's going to show a lot of the things that they went through to develop this application. This is a Silverlight app. Some other things to think about when you're designing. Some of these new devices, like the slates, support screen rotation. So if your existing application or you're designing an application, you want to think about what happens if you have it in landscape. What's it look like in landscape? What's it look like if I suddenly turn it into portrait, right? So on these devices currently on Windows 7, what basically is happening is it's changing from landscape to portrait. So you do get a flash and you see repaint. So you want to think about that with your application. How does it handle changes in screen size? A lot of these devices don't have keyboards. So if you have a lot of text entry, how are you going to handle that? Different development environments have different functionality in this area. There is an on-screen keyboard that's built into Windows, but different development environments, there's some do it easily, some don't. Some you have to actually implement your own virtual keyboard. So think about what you're targeting and whether or not the device will actually have a keyboard. High DPI, a lot of people don't think about high DPI, but what that basically means is in Windows, there's a setting to run the fonts basically bigger with more dots per inch. And what that does is it reduces your effective resolution, so your controls might not fit as well as they did on a normal DPI setting. You'll see this more and more, especially on these Slate devices. They bump up the DPI to the next level, which is 125%. So your effective resolution goes down, and it can cause some compatibility issues in your application as well, depending on how you wrote your application. So high DPI is something you should consider, and usually you'll see the problems right away when you want to run on one of these devices because they are set at high DPI, and that's just because they want the fonts, the buttons, everything to be a little bit larger, so you can target those things in Windows and current applications. You don't want to forget about mouse and keyboard support. Touch is great, but there's a lot of existing Windows application or Windows desktops out there that still use mouse and keyboard. So you want to support touch, but think about mouse as well. You want to make sure that you support mouse and keyboard as well. And one more point about performance. Again, if you should think about performance from the beginning all the way to the end, and you want to maybe even do a proof of concept with the particular functionality that you're going to create inside touch, and also what development environment. Okay, so here are the kind of the three main things you should think about when you're trying to choose a development platform. The first one is what scenario you're trying, or functionality are you trying to achieve? Is there a gesture that you have in mind, like, man, I really want to do a zoom, or it really makes sense for me to do panning? So those are things to think about. Are you targeting cross-platform? Do you have deployment requirements? Does it have to? Does an administrator have to? Do you have to have administrator rights to actually install it? So those kind of things, because each development platform is different for those. Think about your skill sets. If you're a native code guy, then you're probably going to use the native APIs. If you're a .NET guy, then you might choose between Silverlight or WPF. And then based on what scenario you're trying to do, you may choose one over the other. If you're trying to leverage some existing code or target maybe I want to create something on the desktop and I want to leverage the code on the phone, things like that, you want to think about that's going to influence what development platform you're going to use as well. So here's what you can write in. So native code, so you have full control over the APIs, full control over the Windows environment. So the native code gives you basically the best. I think our screen's flickering here. Hopefully it's both flickering here and over there. Hit the A? Okay. All right, I am on A. Let's go to C. Go to A. Okay. Should I try B? Oh, I think this went into standby, and then it maybe that affected something. Okay. All right, so I'll make sure that stays on. Okay, sorry about that. Native code gives you basically the full control. You can do the most with native code because you have direct access to the APIs. .NET is a great choice. WPF tends to give you more control over what Silverlight gives you. And the reason is Silverlight is cross-platform, so you have less control over actually the Windows platform, right? So they have to make it a little platform agnostic, so you're limited on Silverlight on what you can actually do on the actual platform. And I'll show you some stuff in the demos, what I mean by that. IE9, I like bringing this up just because HTML5 is there in 9. HTML5's there's a lot of buzz about it. A lot of the modern browsers are supporting it, including IE9. IE10 will support even more. There's touch support in the browser, so a lot of things are converted automatically for you. So just by writing in HTML5, if you have a simple application, you can actually get a pretty good experience in the browser just by using HTML and specifically HTML5. Silverlight will run in the browser as well, so I put it over there. And in the demos, we'll see some of the differences between Silverlight in browser and out of browser. So here's a slide to kind of show what the different levels of touch are available, like what you want to do with touch, and what each platform supports. So at the raw touch data area, which means that every finger that I put down on the screen, I get touch, basically a raw touch point, and the information, the coordinates, and the position of those fingers, and how many there are, and where they are. So that raw touch data, you can get that basically in all the development environments. Moving to the next one, single gestures. Gestures mean I'm going to take that raw input information and abstract it a little bit for you and say, oh, they're pinching. They've got two fingers down and they're doing a pinch. So a gesture is taking more than one touch point and giving you information about that gesture. So that can be done both in native and as well as .NET, meaning WPF. Silverlight does not have gestures. You have to just work with the raw touch information. Gesture combinations means that you're doing things like a scale, so a zoom or a scale, and then a rotation at the same time. So that's a full manipulation that you're doing kind of a combination of two things at the same time. So to do that, you need either WPF or you need Windows 7 native, which is C++. Okay? So again, so depending on what you want to do and what those gestures are, what's your scenario, it's going to impact which development environment you can use. One quick thing, you can use DirectX. DirectX and XNA, because they have tight integration with the platform, you have kind of access to the core APIs in each one of those, so you can do it. There's less help there, meaning like there's not necessarily an abstraction for you or a library to use, but you can use the raw APIs to actually in those. Yeah. Inside the browser? Okay, so the question is, I'm running IE9 on Windows 7. What's exposed to me? Basically, nothing inside the browser is exposed to you. What happens is mouse promotion. So what happens is the IE9 browser detects that you're maybe zooming. You're doing a scale. And then what it will do is it'll do the zooming for you. So you don't actually get any information. Now, if you have a Silverlight in-browser application, you do get the raw touch information. That's going to be passed along to you. So there's in IE9 in the web browser, basically you're relying on the web browser to convert the gestures into mouse movements. Okay, so on to demos. So the rest of this is just demos. I'm going to walk through each one and show you the kind of the pros and cons of each one. So let's start with native. I'm going to switch over to the demo machine. Are there any other questions before I go into demos? Yeah, right there. Yes. So it depends. IE9's got the best support. Other browsers basically work. There is some integration in Firefox as well. Some more support, but other browsers you kind of have to test them because it would just be like a legacy application on Windows. So just a standard, like if it was Word or you name it, just any application. Basically, it's going to not support any of the gestures, and they get translated into mouse moves. So if you do a touch down, it gets converted into a mouse click, right? So so that's kind of the best answer I can give. Is it depends on the browser, but most of that is going to be the translation or the mouse promotion into mouse moves. Okay, so here's a legacy application. I'm just going to run it. So this is straight C++, nothing fancy. I do create windows, create these windows and buttons. And this is what I call the legacy app. It's like my demo app. I touch enabled it. So if I touch the screen, you can see what I'm doing is I just have a simple message loop and look for certain messages and then write out to the screen, right out to this list box. So you can see I'm actually touching the screen and I'm getting this thing called gesture notify. So this particular application uses the native gesture messages. You can either get gestures, which are like, okay, so now I'm going to do a pinch, and I'm squeezing and pinching, and you can see that I'm getting a bunch of Windows messages telling me what I'm doing. So I'm going to try a rotate. You can see I get a rotate. So this is what's happening under the covers. Basically, Windows is seeing that you're touching the screen from the digitizer and converting it into special gesture Windows messages. I can also register for WM touch messages, which are the native, just raw touch information. So that's the things that you can do in native. What Silverlight and .NET and WPF do is use those WM touch messages that Windows is providing and then abstracting it into each one of the environments. So this is native. I'm just going to show you the code really quick on how this works because they're all based on this behavior, right? So all I have in here, if I scroll down, I'll show you the main message loop for this application near the bottom here. Okay, so there's a message loop, and I look for certain messages. I look for a WM gesture, and basically there's a structure, and I look in that structure, and then I can find out information about the gesture that's provided. So I can see here inside there, if I have a zoom, I spit out gesture zoom. If I do a pan or a rotate, I'm just getting that information and doing it. So you can take all that and basically write your application to support that. So I'm going to quickly jump over to another native application. This comes from the SDK. So you can, if you load the SDK samples, you can actually run this yourself. And this does the native WM touch messages. And I'm just going to go ahead and run it. So this becomes even more complex. Gestures are pretty easy in native. Manipulations get a little harder because you have to basically implement a manipulation event sync. And so what happens is it's grabbing those and then it's passing it along to the manipulation event sync, and then rendering that on the screen. And then if I click, so basically I'm doing a flick, I'm letting go, and you're getting a little bit of inertia. There's another thing, you can implement a inertia sync. So once the manipulation is over, then you can send it off to this inertia, and it'll decelerate the object for you. So the one thing I wanted to show in here is I've got pretty good performance, and then I'm doing things like zooming and rotating at the same time. If this is only a 2-touch point machine, I could grab all 4 and move them around. If it was 4 touch point, I can only do 2 here. So again, you get the full fidelity of the functionality in native code. Yeah, go ahead. Yeah, great question. So the question is it a 2-touch point machine because of the hardware? The answer to that is yes. It's based on the digitizer that's used and the driver that's used. So sometimes they will, this is a capacitive screen. This capacitive screen may be able to support up to 10 touch points, but because of how they implement the driver or lots of hardware reasons, they may only want to implement 2 touch points. So you'll see all the different ranges. Most will be at least 2 touch points. Capacitive screens handle the most. In the slide where I said there's touch screens that you can buy, 3M makes one that supports 30 touch points. But just the display alone is, I think, $1,500. So just the display, because the capacitive screens are very expensive. So it is a hardware. It's not a Windows issue. It's a hardware issue. And with however many touch points you support, generally the price goes up. So okay, so that's native. Let me then switch over. Okay. Just switch. Well, I don't need to go back to the slides. My next slide says I'm going to go into WPF. So I'm just going to go straight into WPF and show WPF. Any questions on native before I move on? I think we have one native guy, so it's you, the guy that knows everything. So any questions? Or?
Can I determine the state of the modifier key?
State of the mod. So, oh, okay. So, so the question is, can I find out whether or not somebody's got something pushed down on the keyboard? So, I mean, you have in native code, you basically do it the same way, right? So yes, you can get anything in native. So, so yes, you can get the keyboard information there as well. So, so that's a good question. What I will say about native is the SDK is really good. It explains how to use that. It's got really good samples. So if you want to look at native, the SDK is the best resource for that. All right, let's go to WPF. So this is a very simple solution. I'm going to just run it real quick. So basically, I just created a WPF application, and I put a text box on it. I put a password box on it. I put a list box and a button. And there's not really there's actually no touch-specific code in this sample. But what I want to show here is the fact that I can touch it, and I'm getting, it's showing that I'm clicking the button. I'm writing here, login click. So basically, I just write to this screen, and when I click, I can actually pan inside here, and notice I'm getting a little bit of feedback when I get to the top of the list. You see it bounce, scroll up and down. If I click in this text box for user, notice that this little on-screen keyboard icon pops up. This is called the TIP, the text input panel. It's been around since tablet PC. I get that all for free in WPF. So I didn't code any of this specifically. So if you have a native WPF application, it's probably going to, a lot of the work's probably already done for you in WPF. One disadvantage, and that's why I have the password box here, notice that I click on the password box, I don't get the tip. All right, so if I click here, I get the tip. If I go password box, I don't. That's a disadvantage. For some reason, on WPF, they decided not to expose the tip if it's a password box. So you would actually have to create your own virtual keyboard for password if you wanted to support having no keyboard. So the other thing I did in here, I'm going to try this and cross my fingers. I put in some code for rotate. I'm going to rotate this. Notice that I got a lot of cables running here, so let's see. So you guys are going to have to turn your heads. So there you can see that it rotated. I don't know if you can see in the title, now it says portrait view. So I just do a detect on the screen size and rotate it. Again, that's not necessarily touch specific, but those are some things that you need to think about. Now I went back to landscape view. And I did actually move some of the controls around as well. So basically, I want to show you that real quick on how I did that in the code. So let's see here. So if I go to, I'm going to look at the XAML first. Sorry, the font's really big. Can't find anything. What I wanted to show is where I wired up the size change, and I can't see it in there. So anyway, I wired up the size change. I don't see it, but basically what it does is, so I get the size change, and then I do a detect rotation. And then all I do is look for the kind of the width and the height and decide whether or not I rotated the screen. So again, it may not be implementing necessarily touch-specific stuff. It's thinking about running in this environment and how you need to work inside of it. It's not just the APIs that are specific to touch. So that's my app. So again, this is just a standard WPF. I got a lot of touch stuff from it. The next thing I want to show is this WPF touch walkthrough. You can actually walk through this yourself. It's from MSDN. It's a really good application to kind of get you started on actually implementing touch inside WPF. So let me just run it so you can see how it works, and then we'll look at the code. So all it does is draw a rectangle, and then I can move this rectangle around, so I'm doing a pan. But I also I can get zoom, right? And I can do the rotate. So a lot like what we saw in the native code app, I can do with WPF. But you'll see that the code's way simpler. I didn't step into the native code, but I kind of referenced it, saying that you have to set up an event sync, and you've got to do an inertia sync and all that. Let's take a look at WPF and see how that works. So it all basically comes down to just wiring up a few events. So we've got manipulation started, delta, and inertia starting. And so you create handlers for those. And then you also say, whoops, down here, in the canvas tag, if you set whatever object you want to support manipulation, you say is manipulation enabled true, and then you'll get the touch events, okay? Or those touch events will fire. And then if I go back here to my code, here is, let's look at starting. You just kind of have to set up the container, and then all the real work's done in the manipulation delta, which means that something's changing, right? So these are fired when something changes, and you just do if you want to do a rotate, you just put in this line. It's pretty straightforward. You do a rotate at on the object. If you want to do a scale, which is the zoom, you do a scale at. And then the translate is the panning. So depending on what you want to support, that's all the code you have to actually do. So it's very straightforward. Anything that's, or a lot of the controls that are based off a UI element in WPF support this. So pretty much, so you can do UI element and content element, which is pretty much all the controls or the base controls that you would use in a WPF element, or WPF application. So it's pretty powerful. So you can do a lot in WPF. So that's that sample. What I wanted to show was a real application that used it. So one of the shipping applications that you can get you can download off of Windows Product Scout is PressReader. This is a WPF application. It's basically a news reader. If I click on, let's look at the Vancouver Sun. So if I click on it, you can see that I've got the image of the actual paper here. If I do a swipe, basically, I can read through the paper. It does support the rotate. I won't do the rotate because of all the cables I have here, and then you'll have to read it sideways. But you can also change the view into this Basically, they take the text and optimize it for the screen. Then I can scroll through that. I can drill into a particular story and read through it. So you can see that the response is pretty good in here. The touch integration's good. They have a good layout here. They've got things that are easy to click. So I would call this touch optimized because I get good feedback. I got nice big targets. I get good performance. So this is a good app, and this is a WPF app. Okay. All right. So let's move on to Silverlight. Now, well, any questions on WPF? Okay. Okay. So again, we'll start with my super simple demo, which is basically just creating a new Silverlight app and seeing how it performs inside Touch. So Silverlight can run in browser or out of browser. So let's first take a look at the behavior inside in browser. So I'm running in browser. So I will run it here. So I have a text box here. So I'm clicking on it or tapping on it, and nothing's happening. So the caret appears, but I don't get the tip. So again, this is kind of the cross-platform issue, where because that's Windows specific, they don't expose that. So, and there isn't really a good way to call the API inside Windows, which is set caret, to actually get it to show up. Okay, so that's a disadvantage. I'm going to click this button. You can see I get a bunch of stuff here. I'm not getting the panning, the scrolling view. Notice that it's kind of just selecting, so I have to kind of use the scroll bar here. So not the best in Silverlight, especially in browser. One thing I do get is pinch zoom, okay? But that's really the browser doing that for me. It's not Silverlight. One thing I did implement, basically what you're getting in Silverlight without actually putting any touch APIs in there or doing the touch enablement is mouse promotion. So if I do a right click here, you can see that I actually did get a right text box, right mouse down. So I get a little bit, but it's really not that great of an experience. So let's look at out of browser. And lost it. There it is. Okay. So here it is out of browser. I still don't get the tip. Again, that's a cross-platform thing. But I can get some information from the actual Windows environment. So I can get the height, right? This code ran, and basically I had a try-catch block around the thing that gives me the height, because in the browser, I don't have access to that. But I do here. So I can click this button, and I'm getting the height and the clicks. But it's still kind of the same behavior here. I'm still limited. Now I don't get the zoom. So again, not the best experience at this point. The next thing I want to show you is actually turning on the basically the touch events so I can get that information. So all that was mouse promotion. Okay, so it was getting converted to mouse messages. So I'm going to uncomment out this one line. So what you need to do is basically wire up this event. So it's touch frame touch frame reported, the touch frame event handler. So I wire this up, and when I do that, I scroll down here and look at my event handler, I get basically all the touch information, and all I'm doing in here is for each touch point that I get, I'm going to report what's happening, whether or not I got a touch down for that touch point, a move, a touch up. So, and I'm just going to report that out to the list box. Right. So I'm just going to touch, so you can see I'm getting a touch down, somewhat of a move, and a touch up. And if it's not good. All right. Okay. So anyway, I think it actually crashed on me there. So the way I have to actually, this is interesting. This device, this has no VGA out, so I have to use this device. So I think I actually crashed it. Yeah, I might have moved. I might have clicked pretty hard there and wiggled something. Okay, so basically, while this comes back up, let's see if I can get the screen back. Okay, good. So just give me a moment. I'll get back to where we were. But what's going to happen when I bring this back up is basically what I wanted to show was I was going to put 2 fingers down and you'd see double the messages, right? So I'm getting it for each message. So actually, I'm going to just move on to the next demo to show how that works. So there is a good sample app from Charles Petzold. He's like the Windows guy, right? He wrote some great Windows books. He also does a lot of touch stuff. He's got some good samples out on MSDN that show touch in Silverlight. And I'm going to run this one. So he basically is getting the raw touch information, and he's going to render it on the screen, and I'll show you. And you actually get pretty good performance doing it this way. So he just writes this object called touch out to the screen, and I can rotate it, I can spin it. Again, you're seeing that I can do multiple manipulations, right? So multiple gestures through manipulations and do it. And he even wired up the keyboard, so the mouse, and I can move it around that way as well. Let's look at his code real quick. So he's basically doing the same thing here. Touch frame reported on the on-touch frame reported event. And then let's just look at his code real quick. So here's the handler. What he does is he grabs each touch point. He creates a collection and then runs through the touch points and then decides on what you're doing and does rotations and figures out whether or not you're zooming or scaling and does some. He has to do some math and some calculations there, but it's not too bad, and the performance is good. So you can do the same thing in Silverlight. But there are some disadvantages in Silverlight that you saw, that because you're not as close to the platform, because it's designed for cross-platform, that there are some limitations, like you can't display the tip, and depending on if you're in browser or out of browser, there's some limitations. One other limitation of Silverlight is if you run full screen Silverlight, they made a decision in the platform that if it's full screen, they basically turn off all the touch support. So you can't actually have a full screen Silverlight app and do what I just showed there. That it's not supported. So another disadvantage to Silverlight. Okay, so I've got a couple Silverlight demos. USA Today is a shipping application. They did theirs in Silverlight. And it's also, obviously, a newspaper reader. And it is pretty good. So I can do the scrolling here. I can click into stuff. Here, let's soft flash again. Oh, there we go. Okay, I'm going to touch lightly. I don't want to wiggle anything. Okay, so you can see that I can pan around. I can scroll across. So they actually have a pretty good experience here. And again, this is with Silverlight. There's another newsreader that I'd like to show you. This one is by Tribune, called Mosaic. So they're also a newspaper company. So they bring up this almost like a screensaver and show you like key images from stories, and then you can click on the story. Sorry, it's updating. And then click into the story. There it goes. And kind of have that same experience. And I get some inertia. Now they had to code that inertia themselves. So again, you don't, there isn't, you have the raw touch information in Silverlight. So if you want to do something like this inertia, you're going to have to code that yourself. It's not like what you have in WPF. Okay. Oh, one more thing. Since I got a little bit of time here, I'm going to show Flickr. This is also Silverlight. And I really like this interface. They kind of had these blades. So you've got these images here, and then if I click over, it kind of exposes these blades, and then I can scroll up and down inside these. And then I could click and view and zoom. One disadvantage to here is if I click on that search, notice that they didn't implement their own keyboard. Because I can't display the tip here, I'm kind of stuck. On this device, if I didn't have this Bluetooth keyboard, I wouldn't be able to search. So you can, as a workaround, add like the, let me show it real quick here. Add the toolbar, the tip here. So now I have it here in my taskbar. If I click it, I can get it. But that's a little much to ask for the users. They might not know how to do that. Okay. Any questions on Silverlight? Yes.
When the user clicks on that, can I programmatically have a bit handler that will get up to it?
So when the user clicks on here, oh, on the actual text box. Unfortunately, no, there isn't really a good way, and the reason is kind of Silverlight blocks that. That's too low level because it's Windows specific. There isn't really a way to do it. The way you do it in native code, and you can do this in WPF as well, is you can call the Windows API create caret. And that automatically creates the tip icon wherever the caret is, and that's basically how WPF is doing it, because that's what happened. So WPF doing it for you automatically. You can even call that API from within WPF, but Silverlight they block that. They don't allow you to do it. You can't get access to it. So unfortunately, there really isn't a good option in Silverlight other than implementing your own keyboard at this time. I'll say that at this time. That's the current state of it. Okay, so HTML5. So this is a very simple HTML page. If I click on username, I should get it. There's the tip. So basically IE9 is doing this for me. So it knows that that's a text box. It displays the caret. I get the tip. Password box. Notice that it gives this to me. So this is an advantage over WPF. I can type in this password box, and it's a normal password box, and it doesn't show what I'm typing. What I'm doing in this example is I wanted to show some things that you could do inside HTML to kind of support a Slate device. So if I have this select box here. I can kind of scroll through it. What I used was CSS3. This is CSS is basically the style sheet inside HTML, or as part of the HTML standard. As part of CSS3, there's these things called media queries that say, depending on your screen size, it will adjust the layout. So depending on the screen size here, I'm modifying the width of that particular box and changing the color. So I'm changing that style sheet. So the idea here was I wanted to show that you can handle things like rotation and changing the layout just with standard HTML support and CSS3. The interesting thing here is I was doing a pinch zoom there, and I don't know if you saw it, but it was actually based on the size of the text. It was changing the media query as well. I do have a few examples in HTML that I'd like to show you once this comes back. Should be shortly. So I actually, even though there's not a lot of support in HTML5 natively, because the browser supports it, it actually is a pretty good experience. And I'll show you that with some samples. And these are straight HTML5 samples. So I'll just bring up the browser. So this comes from the IE Test Drive site, and this is where they have a bunch of samples that show off HTML5 and CSS3. This is using media query. It's just all it does is there's some CSS that basically says, based on the size of your your screen width, I'm going to apply a different style sheet. So here we see that they're showing the photo, some text about it, but as I change the size of the screen, notice that they change the style. I can do it with the mouse here. See how they're changing the style of it and changing how much stuff they display. So this works good if you're switching between portrait and landscape to handle a rotation. Here's the actual, this is what it looks like here. I can show you in my code, but this is basically, it's a very simple way to implement this kind of really cool functionality. And then the next thing I wanted to show you was just an HTML5 app that's pretty good. This comes from the Test Drive site as well. It's Texas Hold'em. And you can see that I can play this. I'm not going to rotate the screen. I'm going to simulate a rotate by changing the size here. But you can see that they do some resizing. Well, it actually does. Maybe I will try a rotate real quick. Cross your fingers. I'll do it. Should have had it maximized. Guess I have it zoomed a little too much. You can see they're just doing some creative style sheet layout type stuff. It's really powerful inside the browser to do that resizing. So you can see it's going to keep going. I'm going to rotate it back. And it's still running. They're still playing. And you can get a pretty good experience there. And you know, I'm clicking on things. You saw me click on call. Let me call again. I'm playing this game, and it's a pretty good experience. You know, I can zoom it. I can click on things. It's easy to make large targets inside HTML. So it's definitely an environment that you can use and get a pretty good touch experience. That was the main part of the demos. I'm going to flip back to the slides real quick, and we can summarize, and then we have a few minutes for questions. So summary, you know, the touch is here. It's been here since Windows 7. There is hardware, lots of different hardware, not just the Slate devices. We've got a lot of different diverse hardware out there that you can design for touch. I think the best thing to do is kind of, if you have an existing application, just try it, see what you have to tweak. You know, maybe you can get what you need just through mouse promotion, and you don't have to actually implement some of the APIs. You want to pick a development environment based on the pros and cons of each. I've got some blog posts that I summarize what different things you can do in the different environments and kind of the pros and cons of each one. So you want to really think about your scenario. You want to think about your requirements, think about your skill set, how you want to leverage what you currently have. So it's definitely, you want to do some planning before you get started. And it definitely pays off as opposed to heading down a certain path and then getting stuck, like say in the Flickr example where, oh wait, I don't have a keyboard, they can't do a search. So, and then you have to implement your own keyboard. So that's it. I do have some giveaways here for those people that stuck around. And so I need to think of some questions actually. Are there any questions? Oh, some guys want, is the question, can I have the Power Stick? Okay, go ahead. Meaning that, you know, a pinch does a zoom or whatever. I'm not aware of one. You know, I guess it's kind of a natural thing. You would think that there would be something out there. I guess it's kind of the first guys to implement it. They get to kind of call the shots. There's kind of already an expectation on that. So I don't know of any. So, and I'm gonna do a trivia question for the giveaway. So, sorry, you might get it though. What was your question? So the question is Microsoft planning on improving touch? I think is the question in the next OS. So obviously there's been investment in touch. So the way I've kind of delivered this presentation is kind of giving you the guidelines, the what to think about, how it works under the covers. Microsoft traditionally wants to support what would he say? That they support backwards compatibility. So kind of the investments that you make today should be implemented in the future. You want to follow the guidelines. You don't want to do something really funky, like, oh, Silverlight doesn't support this, so I'm going to do this wacky thing and, I don't know, write a COM component that does something. You know, you want to stay away from that. You want to stick within the platform's abilities today. That's about all I can say on that. So, so there is a next OS coming, and you know, obviously they want to support this kind of hardware in this form factor. So I don't know if that answers your question or not. All right, so trivia question. Let's see. Does Silverlight support the text input panel? Wait, you gotta raise your hand. I saw a nod. I don't know. You shook your. Oh wait. All right. So who put up their hand first? This isn't working well. I'm not good at giveaways. All right. Go ahead. Yeah. I'll give it to you. You did raise your hand. Input text panel. Yeah. No, it does not. That is correct. Okay. All right. So what's my next question? What development environment gives you the most flexibility? Oh, I think this guy right here. Native, yeah. Okay. Sorry, if that wasn't very fair, I'm sorry. I'm not good at giveaways. But thanks for coming. If you got any more questions, I'll stick around.